in this video, we're going to be doing a released AP Computer Science released FRQ. So consider the design of classes who store cities and postal codes. A city such as Miami, Florida may have several postcodes. A postal code may occasionally represent more than one city. For example, the postal code 95324 is used for Hillmar, California, Irwin, California. Postal codes may include letters as well as digits. The class postal code stores information about cities and postal codes. The initial version of the class is shown below. Cities and postal codes are represented as strings in the class. So here we have our general structure. Let's see, strings, okay. For the implementation shown above, give the big O running time for the postal code database methods, get cities for code, and add city code pair. Express your answer in terms of n, where n is the number of city code pairs that have been added to postal code database. So here we have map string set string code to city map. So what this means is string, that is your key, your postal code, and we can see that our value is equal to the set of cities. Now we need to know what our hash map access time is. Our big O is going to be O of 1. And here we have O of 1 as well. So when you have hash map, when you use get for key, that is O of 1. When you have put key value, that is O of 1. Hash map uses hashing. When you read the method and you have return code to city, get code, this is one hash map lookup. So this is O of 1. Now here we have our second method. Set string city set, get cities for code. If city set is null, city set is equal to new hash set. Go to city put, map.put code city set dot add city. So what we see here is get is O of 1, put is O of 1, and adding to your hash set is O of 1. So the big O's are O of 1. Now, right now, what we have is code to cities. But our question is, if you have city, you want to find all codes. So what we want to do is a reverse lookup. But our current structure, it can't do this efficiently. Because what we have here is that we would have to loop through all postal codes. And you would have to check each set. And this is currently O of n. So what we have is when we have our lookup direction reversed, what you need to do is you need to have a second map. So what we have to do is we have to add another map. So what you're gonna have is map and you have city to codes. Now going back to get cities for code. In get cities to code, when you have get, it calls get on the hash map, which is going to retrieve the value associated with the given code. This operation uses hashing to directly access the correct bucket, so it's constant O of 1, because you have no loops or additional operations. Now, for public void add city code pair, string code string city, the line set string city set is equal to get cities for code, calls a previously defined method get cities for code, which performs our hash map using get. Since this is O of 1, retrieving the set of cities, or null if it doesn't exist, is going to be constant time. That's when it does not exist. Now, if city set is equal to null, this checks if the postal code is not already in the map. This is just comparison, and comparison is going to be O of 1. Now, for city set is equal to new hash set, this is going to create a new empty hash set to store cities for this postal code. So creating a new data structure is constant time. Which is also O of 1. Now for code to city map dot put, this is going to insert a new key value pair into your hash map. For put, that operation in a hash map is going to run O of 1 on average because it uses hashing. Now for the line city set dot add city, this is going to add city to the set. Adding an element to hash set is O of 1. So since every single line in this method performs a constant time operation and there's no loops or nested operations, the total running time of add city code pair is just going to be O of 1. So let's move on to part B. The postal code database class is to be modified to provide 2 additional operations. A new method, get codes for cities, should return a set of all postal codes for a city. This method must return in time O log of n or better, where n is the number of pairs that have been added to this postal code database. A new method, print all cities, should print an alphabetical list of all cities. This method must run in time O of n or better. In the spaces below, describe your modifications to the design of the postal code database class to support the new functionality listed above. Declare any additional instance variables that are required in the postal code database class. Show the initializations of these variables in the postal code database constructor. So, for our instance variable, we can start by writing City to code map. So this declares a new map will store a relationship from city to set of postal codes. The key is going to be string, and the value is a set of postal codes, which is set string. So this is necessary because the original map was code to cities, but this new map is reverse, and this is us going from city to codes. Now let's look at our constructor. For a constructor, we have to write some additional instance variables. So we're gonna write and this is because this is going to initialize the original postal code set of variables. And this is still going to be O of 1 because this is lookup, average. Your average time is lookup and insertion. Now, this is this part. So this part is gonna a tree map is gonna keep your keys, which are cities, stored in alphabetical order. Which is going to be useful for later when we have our operations like printing these cities alphabetically and when we want to achieve a later O log of n time. There's also a second version that you could have done this with. So instead of using those additional instance variables, the second version you could have done is private mat string set string this first line is gonna of all postal codes from a given city. Now, for your private set, this is going to be a set that stores all city names. You use this to keep the cities in a sorted order so that later you can print them alphabetically. Now, we have another option for our constructor as well. For your constructor, you could also do, so here you had your public coastal base. Can we write this? It would look like so in Coach's City map, new hash map string. Now, city to code map is equal to new hash map. This is going to initialize the reverse mapping where you're gonna go city to postal code using a hash map. So then you get fast O of 1 lookup when you're retrieving postal codes for a given city. Now, for cities is equal to new tree set. All cities in O of N without So on the left side, what we do is we use tree map, and your sorting is built into the map. Now on the right side, you're gonna use tree set, and your sorting is handled separately. both of these methods, they're going to allow reverse lookup, alphabetical printing, and a runtime of O of 1. So our additional instance variables are going to introduce a reverse mapping from city to postal codes and optionally a sorted structure by using either map set or tree set. Map set or tree set are our options. So you had those to efficiently support our required operations like fast lookup and our alphabetical printing. Now, explain how a postal code database class will use these additional instance variables to organize the data. So, city to code describe any changes that are needed in the method add city compared to update the additional instance variables. So that was actually for that side, I realized. So city to code map will map to set of codes. There's a second version that we can do. An explanation for, so city to code map. Now we have to justify and explain. Tree map is the data structure being used? That's when you have a balanced tree. This is an example of operation being run. Hash map uses hashing. In hashing, you get direct access to values using a key. This method is O of 1. In hash map, you have constant time on average. When the key is hashed, you jump directly to the location. So dot get key is O of 1. This is just an example operation. So remember that tree map is O log of n because of the tree structure. And hash map is O of 1 because of hashing. So here we see that city to code map is implemented using tree map. The get method is O log of n because it performs search in binary search tree. Now, you could also say that city to code map is implemented as a hash map because the get method returns an O of 1 time on average because it uses hashing to directly access the value associated with the key. For part D, write the postal code database method that prints all cities, which prints an alphabetical list of the cities in postal code database. This operation must run in O of n or better, where n is the number of city code pairs that have been added to the postal code database. Complete method, print all cities below. So, This declares a method that prints all cities. That's your return type, which is nothing. Here we see and city to code map is a tree map. So values are already in alphabetical order. Now for system.out.println, this is your second version, which is iterator. So this is the same one as before, where we get the cities in sorted orders. Our system.out.println Now, this last version uses an enhanced for loop. And then this line prints each city one by one in alphabetical order. Now we also have a tree side version. So this first version was using tree map. So to explain this code version, this first line, public void print all cities, now for our second version, which is an iterator, and cities is also a tree set that is already sorted. And then this prints each city in order. Now, this is our enhanced for loop. And tree set is when you have something that's sorted alphabetically again. This prints each city. And this is an O event time because you're visiting each city exactly once. You have no nested loops, and you have no sorting happening during the method because it's already sorted. Therefore, you have O of N. So your cities are already sorted with either tree map or tree set. The method iterates through all cities once, so the runtime is O of N.